Hello, I'm going to go over this worksheet, Pressure and Gravity, Stars and Supernova. And what we're going to talk about, we're going to look at 3 examples, and you're going to write in the same notes that I write in. And we're going to talk about where the forces are working as these stars eventually get older and come to the end of their life cycle. So let's start with our sun. So our sun, just like any other star, has fusion going on in the center. And the fusion is pushing outwards, exerting a force, pushing outwards on that star. Now this is opposed, thankfully, by gravity. Gravity wants to pull this all inwards. And that's why, with these forces being equal, our star remains the same size. Okay? So that's good, that's stable. Now, as the star gets older, you start to get a core. You get a core collapse. And as the core collapses, it's collapsing because of gravity. Fusion is starting to stop. Gravity is crushing that core smaller and smaller. But the outer layers are actually pretty far away, and they're not being crushed along with the rest of the star. These outer layers still have the old pressure on them, pushing them away. So these outer layers just slowly start to drift away as this core collapses. This is the red giant phase that our star will go into. And then finally you have your white dwarf. In this case, gravity, white dwarf is small, right? So it's about the size of Earth. Gravity is crushing down on the white dwarf. But it doesn't keep crushing down because eventually you have this opposing force from the white dwarf. Remember, all the atoms now are smushed together. And the opposing force is called electron pressure. Basically, electrons, which are negatively charged, are pushed as close as they can get to each other. Negatives and negatives don't want to be together. So that's as close as they can squeeze all these atoms together. And now it's balanced. This white dwarf is balanced. It's just you took this mass of the sun, squeezed it down to the size of the Earth. Okay? Let's go to a different one. Let's start with a red supergiant. Very big, massive star. When it comes to the end of its life cycle, it's going to collapse into a supernova. So what happens here is first the gravity causes the core of this supergiant to collapse, right? So we'll say, I'll put gravity here. Gravity's causing it to collapse. It does that so quickly and with such force that the outer material explodes off the surface. So this is one of our supernovas, huge explosive force that's opposing gravity, right? So this is pushing outwards. And for some reason I skipped this first part. Let's go back to the red supergiant. And just like the previous one, we have fusion in the middle, matched by gravity. So that super red giant is stable. And then it gets to the end of its life cycle, collapses, and then creates the supernova. Now, the last thing that we have here is a neutron star. More massive than our sun, collapses down past the white dwarf stage into the neutron star stage. And again, you have gravity working here, crushing it down. And it's even ripping apart the atoms that form this white dwarf star. And what you end up with is no protons and electrons, they get smushed together, you only have neutrons. So you have an entire star that's formed from neutrons, but it still pushes back at a certain point. This neutron star, by the way, would be about the size of New York City. So a sun much larger than ours being compressed down into a space the size of New York City. This is called neutron degeneracy pressure. So at this point, gravity can't pull the neutrons any closer together. They're as close and packed as they can be, and now it's stable. Let's go one more size more massive, blue supergiant. So, fusion in the beginning, which is opposing gravity. And it's stable. When it gets to the end of its life, same thing here, collapse and supernova. So we still have our gravity, which is collapsing down. When that material rushes in as it collapses down, it rebounds, creating our supernova. So right now it looks like the last one, right? I'm gonna add rebound here, because that's the force that's pushing it out. And then finally, since this one is so big, it crushes down past the white dwarf, crushes down past the neutron star, and eventually crushes down into a black hole. And at this point, the only force that we're worried about is gravity. As gravity pulls all that matter into a smaller and smaller volume. Distorting space and time, all kinds of weird stuff happen with black holes. Okay, so if you have any questions, let me know.